Welcome back to the deep dive. We are doing something a little different today. Usually when people think about home renovation, they obsess over the finishes, the tile, the vanity.
All the brass fixtures.
Exactly. But today we are going inside the walls. We're talking about uh, the veins and arteries of the house.
Which is arguably where the real anxiety lives.
It is. I mean, if you mess up a tile, it just looks ugly. If you mess up the plumbing.
You can ruin the entire house.
And that fear, it usually drives people to just hire it out or, stick to what they know. But we've got this stack of research from Claude Taylor.
The finale of his series on bathroom additions.
Right. And he's proposing a plan B.
It's a completely different philosophy from the traditional methods.
He calls it a strategic alternative, to the classic copper and wet vent approach. And I want to be clear right off the bat, this isn't a how-to for fixing a leaky faucet.
No. This is about the architecture of a renovation.
We're talking about switching to PEX for water.
And individual venting for drains. Right. It's a study in trade-offs.
Right.
You're trading material costs and maybe some physical space for speed and simplicity.
But is it actually simpler? Or is it just dumbed down? Because when I read plastic pipes and no math required, my skeptical alarm bells go off. It sounds a bit like the IKEA version of plumbing.
That's a fair skepticism, but I think it misses the engineering evolution that's happening here. We aren't just swapping materials, we're solving different problems.
Okay.
Plan A, the traditional copper and wet venting.
Yeah.
It's elegant, it minimizes pipe, it's efficient, but it requires a high level of craftsmanship and calculation.
A lot of skill.
A lot.
Yeah.
Plan B is brute force in some ways, but it solves the specific headaches of adding on to an existing house where you just don't have open access to everything.
Okay, so let's stress test this plan B.
Yeah.
The headline feature is obviously the water supply, PEX. For those who haven't walked down a plumbing aisle in a while, we aren't talking about rigid PVC, are we?
No. PEX is a cross-linked polyethylene. It's flexible tubing. It comes in these big coils.
And the selling point everyone talks about is no torches. Which, sure, safety is great. But is the fear of a blowtorch really the only reason pros are switching to this?
It's not just the fear of the torch, it's the environment where you're using it. If you were doing a renovation in a house built in, say, 1920, that timber is bone dry.
It's tinder.
It is basically tinder. Taking an open flame into a wall cavity to solder a joint is a legitimate fire hazard.
Okay, so you don't burn the house down. That's a pretty big plus. But I'm looking at the connection methods here. If we aren't soldering, we're using mechanical fittings.
Right.
Taylor mentions crimp rings and expansion fittings. Are these actually reliable? Because a soldered joint, chemically, it becomes one single piece of metal. A crimp ring is just...
squeezing really hard.
Yeah.
Well, this is where the nuance of the material really matters and where a lot of people get tripped up. There are actually different types of PEX. You have PEX A and PEX B.
Wait, there are subgenres of plastic pipe now.
Just to keep things interesting. PXB is what you see most often in the big box stores.
Yeah.
It uses that crimp style. You slide a fitting inside the pipe and you crush a copper ring around the outside to hold it on.
It's fast.
It's very fast, and the tools are cheap.
But you said the fitting goes inside the pipe.
Correct.
Doesn't that restrict the water flow? I mean, if I have a half-inch pipe and I shove a piece of brass inside it, I don't have a half-inch opening anymore.
And you've just hit on the major criticism of the crimp system. It does restrict flow slightly. In a high-pressure system, you might not notice, but if you've got low pressure, those insert fittings add friction. Every elbow, every tee, it chokes the flow down just a little bit more.
So that's the trade-off for the cheap tool. What's the alternative then?
The alternative is the expansion method, which is usually associated with PEX A. This is what Taylor seems to lean toward for a higher quality install.
Okay.
You use a special tool to physically stretch the tubing wide open. You insert a fitting that's roughly the same diameter as the pipe, and then the PEX, because it has what's called thermal memory, shrinks back down and grips the fitting.
So no flow restriction?
Negligible.
Yeah.
It's essentially full bore, but the catch is the barrier to entry.
The tool.
The tool. An expansion tool is significantly more expensive than a crimp tool. You're talking hundreds of dollars versus maybe $50.
So plan B isn't necessarily the cheap option if you want to do it right.
Not at all. You're investing in the infrastructure of the tool set.
Right.
But think about the labor costs or just your own time if you're a DIYer. With copper, every single time you turn a corner, you have to cut, clean, flux, assemble, and solder. It takes time.
So much time.
With PEX, you just bend the pipe. You snake it around the corner.
That brings me to the renovation aspect. The source mentions fishing lines through walls. This feels like the killer app for add-ons.
It is,
Yeah.
absolutely. Imagine you want to add a bathroom on the second floor. If you use copper, you have to rip open the drywall all the way down to the basement to run these rigid 10-foot sticks of pipe.
Total demolition.
Total demolition. With PEX, it's like running an electrical wire. You drill a few strategic holes and you can fish the line up through the stud base.
You save hours,
Yeah.
maybe days of drywall repair and painting.
It's a massive logistical win.
Okay, but let's talk about longevity. Copper has been around for ages.
Thousands of years.
Copper pipes last for decades. This is plastic. We all know plastic degrades. Are we just building a system that's going to fail in 20 years?
It's just a different vulnerability profile. Copper is great, but it has enemies.
Like what?
Acidic water eats it, hard water scales it up, and in cold climates, if it freezes, it bursts.
Game over.
Game over.
And PEX.
PEX is immune to corrosion. It doesn't care about acidic water.
Right.
And the freeze, this part is fascinating because PEX-A allows for expansion. If water freezes inside it, the pipe can actually balloon out to accommodate the ice.
It's a balloon.
It expands, and when it thaws, it shrinks back to its original shape.
Wow.
Now, I'm not saying you should let your pipes freeze on purpose. It strains the material.
Sure.
But where copper splits and floods your entire house, PEX might just survive the night.
That is a huge insurance policy. But it has a kryptonite, doesn't it? The source mentions UV light.
The sun. Yes. This is the one place where PEX fails miserably compared to copper. You cannot expose PEX to direct sunlight. It breaks down the molecular bonds.
So if I buy my materials and leave them in the back of my pickup truck for a week in July...
You've ruined your plumbing before you even installed it.
Oh, wow.
You have to store it indoors or covered, and you can't run it outside a house for a hose bib without protecting it. It's a vampire material. It needs to stay in the dark.
Okay, so keep it in the walls, and you're good. Now, I want to pivot to the other half of this equation, the drains. Because getting water in is the fun part. Getting waste out is where all the math usually happens.
By venting.
The venting. The source describes a shift from wet venting to individual venting.
Can we demystify this? Because wet venting sounds like, well, it just sounds gross, honestly. It's actually very clever physics. In a wet vent system, your plan A, you use the drain pipe of one fixture, say the sink, to also serve as the air vent for another, like the toilet.
Okay.
You're asking one pipe to do two jobs, carry water down and pull air up.
Efficient.
Very efficient on materials. But to make it work, you have to follow very strict rules. Pipe size, slope, distance.
And if you get the math wrong...
The toilet flush sucks the water right out of the sink trap, and suddenly your whole bathroom smells like sewer gas.
So it's high risk if you don't know what you're doing.
Precisely. Plan B, individual venting, it removes that complexity. The rule is simple. Every fixture gets its own dedicated pipe strictly for air.
One vent per fixture.
The toilet has a vent. The tub has a vent. The sink has a vent. No sharing.
But that sounds like a spider web of pipes in the walls.
It is. It absolutely is. You are running significantly more PVC.
And here is where I get worried about the structure. We are talking about drilling holes in floor joists to run all these extra pipes. If I have 5 fixtures and they all need individual vents, am I turning my floor joists into Swiss cheese?
That is the critical danger zone. You absolutely have to know the drilling codes. You can't just bore a 3-inch hole in the bottom of a joist. You've just compromised the structural integrity of the entire floor.
So while individual venting saves you from doing flow math, it forces you to do structural math.
Oh, that's a great way to put it. You have to plan the route very carefully. However, for a DIYer or even a general builder, it's often easier to visualize.
How so?
This pipe goes up to the roof. This pipe goes down to the sewer. It decouples the whole system. So if you mess up the sink vent, it doesn't ruin how the toilet functions.
It isolates the failure points.
Right. And a lot of local codes actually prefer or even require this because it's just harder to mess up the function even if it uses more plastic.
So we have a system that uses more material but requires less fluid dynamics knowledge. Now what about the layout? The source mentions a manifold system. To me, that sounds like apart from a car engine.
It works on a very similar distribution principle. In a traditional house, you have a trunk and branch system.
Right.
A big main pipe runs through the basement, and smaller pipes split off to the kitchen, then the powder room, then the master bath.
Which means if I'm in the shower and someone flushes the toilet...
The pressure drops in the trunk, and you get scalded. The classic shower shock.
How does Plan B fix that?
By using a manifold. Imagine a central block in your utility room. The main water line comes in there. And then, like a nervous system, individual PEX lines run directly from that block to every single fixture.
Everyone.
A dedicated line all the way to the master shower. A dedicated line to the kitchen sink.
So they aren't competing for flow.
Exactly. The pressure is balanced at the manifold.
Yeah.
So if someone turns on the washing machine, it doesn't steal water from your shower line because they're on completely separate runs.
That is a massive quality of life upgrade. It feels like a feature from a luxury hotel.
It is, but it also creates that spaghetti look in the basement. You have dozens of red and blue tubes running across the ceiling.
But again, if you're fishing lines through existing walls, pulling one continuous flexible tube is way easier than building a rigid tree with 100 soldered branches.
And leak detection is easier. If you have a leak, it's almost always at a connection point.
Sure.
In a manifold system, you have a connection at the manifold and a connection at the faucet. There are no fittings hidden inside the walls to leak.
Wait, hold on. That's a huge point. In a copper system, you have elbows and T's buried behind the drywall.
Correct. And if one of those solder joints fails 10 years later, you have water damage you can't see until it's way too late. With a home-run PEX system, the pipe in the wall is continuous. Unless you drive a nail through it to hang a picture, it's not going to leak.
Okay, that sells it for me more than the no torch thing.
Okay.
The peace of mind of having no hidden joints. But we have to address the transition. Most of us aren't building a brand new house. We're adding to an old one. Eventually, this fancy new plastic system has to connect to the gnarly old copper pipe in the basement.
The tie-in. This is usually the moment of highest anxiety for people.
How do we bridge that gap without using the torch we promised we could avoid?
You have a few options, and this is where the debate gets heated. The easiest way is a push-to-connect fitting, like a shark bite.
Ah, I've heard of those.
You clean the copper, you push the fitting on, it bites in, and on the other side, you push in the PEX. Done in 10 seconds.
But do professional plumbers actually trust those? I've heard mixed reviews.
It's controversial. For an accessible spot, like in a basement where you can see it, most experts would say it's fine. But burying a shark bite inside a wall, many pros just won't do it. The O-ring inside can dry out over decades.
So what's the professional Plan B tie-in?
Usually, they will solder a PEX adapter onto the copper, so yes, you might need a torch for that one joint, or you use a compression fitting. But the goal is to make that transition sturdy and ideally accessible.
So don't just slap a quick connect on it and drywall over it forever.
I would not recommend that. Treat that tie-in as the weak link in the chain. Keep it accessible if you possibly can.
Now, safety. We talked about leaks, but what about the noise? One thing I've noticed in houses with plastic piping is you don't get that singing vibration like you do with copper, but you still hear the thump.
Water hammer.
Does PEX fix water hammer? I mean, it's rubbery. Shouldn't it just absorb the shock?
That is a dangerous misconception, and you're right to bring this up. PEX is quieter for general flow. It doesn't transmit that whoosh sound as much.
Right.
But water hammer is a hydraulic shockwave. It's caused when a valve closes fast, like on a washing machine or a toilet. That energy has to go somewhere.
And if the pipe absorbs it, isn't that good?
To a degree, but the shockwave can still damage the fixtures themselves or the connections. The source is very clear on this. Physics is still physics. You still need water hammer arresters.
The little air chambers.
Yes. Or the mechanical arresters you can screw onto the supply valves. Don't skip them just because the pipe is flexible. Code often still requires them.
Speaking of code, let's hit the golden rule that Claude Taylor emphasizes. Because everything we've said, Plan B, individual vents, PEX, it all sounds great. But is it even legal?
That is the million-dollar question. Plumbing code is not national. It is intensely local.
So what flies in one county might fail inspection just 10 miles away.
Absolutely. Some municipalities are very, very conservative. They might not allow plastic water lines at all. Or they might mandate cast iron drains for noise reduction. If you assume Plan B is allowed, go buy $2,000 worth of materials and then fail your rough inspection.
You're tearing it all out.
You are starting completely over. So the golden rule is talk to your local inspector before you buy anything.
To bring them the diagram.
Exactly. Bring them your diagram. Say, I want to use PEX and individual venting. Is this okay here?
And usually, inspectors appreciate that, right? They'd rather correct your plan on paper than fail your work in the field.
They love it. It shows you respect their authority and the whole process. It makes the actual inspection go so much smoother.
So, zooming out here, we have this shift happening. We're moving from craft-based trade soldering, calculating wet vents, to more of an assembly-based trade, crimping, running dedicated lines.
It's the industrialization of the home. In a way, it's making the systems more robust against human error, even if it uses more raw material.
It raises a philosophical question for me then. We cling to copper. When people buy a house, they hear copper plumbing and think quality. They hear plastic pipes and think cheap. But looking at the data, the freeze resistance, no corrosion, better pressure balance with a manifold, why are we so attached to the old way?
I think it's visual. Copper looks permanent. It looks like a statue. Plastic looks disposable. But in terms of functionality, modern engineering often outpaces traditional materials.
That's a fair point.
We don't drive cars with wooden wheels anymore, even if they looked nice.
We trust plastic for our gas tanks, our medical devices. Maybe it's time to trust it in our walls.
As long as you keep it out of the sun.
Right. Keep it in the dark and check with your inspector. That's the plumb smart way.
Couldn't have said it better myself.
Big thanks to Claude Taylor's research for guiding us through the wall cavity today. And to you, next time you turn on the shower, take a second to appreciate the physics making it all happen. We'll catch you on the next deep dive.